Before we do some questions, let's just refresh our memories on the straight line, standard form y is equal to mx plus c, what the m stands for and what the c stands for. So how does the c affect the graphs? The c value moves the graph up and down and gives us the y-intercept. So let's show that. I am going to make my c value. Let me actually zoom in that we can see a little bit better there. So I just made my c value 1, and then it cuts the y-axis by 1. The c value gives us our y-axis. Then it moves further up. If my c value is by 2, my y-axis is cut by 2. And the same story, if I make my c value -2, then it will cut my y-axis by -2. So the c value gives you your y-intercept. Now let's look at our m. I'm just going to make c 0 again. So then it just cuts the y-axis by 0. Your m. Your coefficient of x there just represents your gradient. What is the gradient again? The steepness of the line, the slope of the line. So it's like when you walk up a hill. If it is a very steep hill, it's going to be difficult to walk up there. That is the idea of the gradient. So let's change to that m value. If I make my m value 2, do you notice there that the bigger the m value, the steeper the line? There we go. So we've got 4. A gradient of m is quite a steep line. And note so far that my m value is positive and my line is increasing. Then if my gradient is a fraction there between 0 and 1, then it's not a steep gradient. And then look what happens when my gradient is negative. So there my gradient is negative. And the line starts decreasing. So positive gradient, negative gradient. All right, and then the deeper into the negatives I go, the steeper the line goes to that side, if I can put it like that. All right, this was just to refresh your memory. In this video, we are going to be doing questions on the linear function or the straight line graph, same thing. If you find that you struggle a little bit or you feel lost and you don't know the details, go back and look at the grade 9 linear function section. There I go through it in detail. It will be worth it. Also, grab a copy of the workbook. So for all the questions that I'll be doing, if you haven't done so yet, grab a copy of the workbook and that you can complete it with me. Okay, let's get going. The first question says that we need to draw a rough sketch of the following. Now you immediately need to identify that as the standard form for your straight line, y is equal to mx plus c. They tell us not exactly what m is and what c is. They just tell us that your m is smaller than 0. So it means that m will be a negative value, and c is equal to 0. So actually, you tell us what c is. C is equal to 0. But now we need to make sense of that, and we need to know what that means. You need to know, this is the knowledge that you need to have. You need to know that the m refers to your gradient, the steepness of the line. And you need to know that your c is your y-intercept. Then, further knowledge that you need to have, you need to know if you have a positive gradient, your line will be increasing. If you have a negative gradient, you need to know, need to have the knowledge that the line will be decreasing. All right, now, let me just, well, they said it can be a rough sketch, so I'm not going to draw lines using a ruler. There we've got our y-axis, there we've got our x-axis. We obviously cannot plot this clearly and knowing exactly where it will be. But we know that c is our y-intercept, and the y-intercept is by 0. So it will cut the y-axis there. We know that. And then, since the gradient, the m value is negative, it will be a decreasing function. So this will be a decreasing function that cuts the y-axis by 0. And there you go. If you were to draw this one, it's still correct because it's still a negative gradient, it's decreasing, and it's still cutting by 0. So there you go. Next question. For question 2, they want us to draw that. They want us to draw that straight line graph. Y is equal to negative 2x minus 4. Okay, again, we can see that we've got a negative gradient of negative 2, and we've got a y-intercept at negative 4. There's more than one way that you can use to draw this. You can use your gradient intercept method. You can use a table to draw this to find the coordinates that you can plot. I'm just going to use the dual intercept method, where I'm going to go plot my y-intercept, and I'm going to go plot my x-intercept, and then I'm going to go connect those dots. What I can tell from this is that my y-intercept is a negative value, so I know where that's going to be. And my gradient is negative, so I know that that would be a decreasing function. All right. My c value, you need to know that that gives you the y-intercept. So I'm going to go count that. Negative 1, negative 2, negative 3, negative 4. There is my y-intercept. And I'm plotting that. As simple as that. Now I'm going to go find my x-intercept. Now think about this with me quickly, grade 10s. Where am I going to find the place, or how am I going to find the place that the straight line cuts the x-axis? Is it going to be there, or is it going to be there? Where is it going to be? How are we going to figure that out? Well, if you think about it, if you are on the x-axis, no matter where you are on the x-axis, ask yourself, what is the y value there? So for that point over there, what's the y value there? It must be 0. And there, it's 0. And there, the y value stays 0. Even though the x value changes, there it's minus 1, minus a half. There it is 2. There it is 2.5. So my x value changes, but my y stays 0. So if I just plug in my y is 0 into my equation, then it is going to give me the place. It's going to give me the x coordinate where this line cuts, well, the x-axis. So to get my x-intercept, I need to plug my y as 0. I need to substitute my y as 0. And that works for every single function. So let's go do that. When I make my y 0, we can solve for x. Now it's a basic equation. I'm going to do that. And then I'm going to divide both sides by 2. And then it gives me that my x is by negative 2. So what did we just do? Let's just make sense of that. We found a coordinate. When my y is 0, my x is negative 2. And remember, grade 10s, you can substitute anything into the place of x or y, and it will spit out the other coordinate for you. So if I plug into the place of x a 10, like this, it will spit out the y value for me. The reason why I plugged in a 0 into the place of y is because that will always give me the x-intercept, and that is what we want. So my x-intercept will be by negative 2, and then we can draw our straight line. All right, just bear with me as I do that. I'm going to have to move that around a little bit. Okay, let me just get it through the right points. I think, yeah, that's not too bad. All right, and there is our straight line. So I'm going to go just label those points. That point will be negative 0 and 2. And this point would be 0 and negative 4. Make sure that you don't swap those around. And there we're done. However you drew this, just make sure that you get the same line. For question number 3, find the equation. Now we need to know that is a straight line. So therefore, the equation that I'm going to find must be in this form. That is knowledge that you need to have. So we need to find the y-intercept, and we need to go calculate the gradient. Gradient, the steepness of the line. Now, for some reason, I see students do this all the time. They say, okay, well, there's my y-intercept, so that must be my x-intercept. Well, no, that must be my gradient. Sorry, that is the x-intercept, but students want to use that as the gradient. It's not the gradient. The gradient we're going to have to go calculate. Okay, my y-intercept, I can see that this graph cuts my y-axis by 1. So that means we already found the c value. As simple as that. Done. Now we just need to go find our gradient. There's different ways that you can do this, grade 10s. I'm just going to use my gradient formula. I need 2 points to calculate my gradient. I'm going to get the change in y over my change in x. So the 2 coordinates that I'm going to use, well, I will just use that y-intercept. Why not? And then what other point can I use? Well, let me use the other point that they clearly gave me, which is -0.5 and 0, which is my x-intercept, by the way. My change in y values, 1 minus 0. I take the 2 y values and I subtract them. And then my change in x. So I'm taking 0 and I'm subtracting a number that is already negative. Watch out for that. And let's just simplify. So that would be 1 over 1/2. Therefore, the gradient is, what is 1 divided by 1/2? Must be 2. So the gradient is 2. Does it make sense that the gradient is positive? Yes, the graph is increasing. So what is the equation for this graph? Gradient is 2. Y-intercept is 1. We found the